We present Mime, a compact low-power 3D sensor for single-handed gestural control of head-mounted displays. Emerging wearable computing displays, like the Google Glass, introduce opportunities for new input techniques and interaction styles suited to wearable constraints. Historically, voice, handheld controllers, and sensor-fitted gloves have been used to control HMDs. They are limited by vocabulary size, requirement for external hardware, encumbrance with markers, or instrumentation of the environment. Among camera-based techniques, RGB cameras are ubiquitous but provide inaccurate gesture recognition, while active cameras are accurate but power-hungry and bulky. Our Mime system overcomes these challenges through low-power compact design that can be embedded in the HMD unit. Mime comprises an omnidirectionally emitting pulsed LED, 3 unfocused baseline separated photodiodes, and a standard RGB camera module. The Mime sensor works by first illuminating the scene of interest with short time pulses, and then sampling the reflected returns at 3 spatially separated photodiodes. The backscatter light is time sampled at sub-Nyquist rates and processed using analog filtering to reject sunlight, followed by maximum likelihood estimation to estimate user's 3D hand location. Now we demonstrate real-time 3D localization and tracking using only the time-of-flight component of Mime sensor. Now we show real-time performance of the TOF component in the presence of a reasonably cluttered background. Individual dots in the trail grow larger as the hand approaches the sensor. Here we show raw sensor data. Notice here that small changes in hand position correspond to large changes in received signal strength. Here we see the power consumption as measured by a digital power supply. The current and voltage readings are easily battery friendly. In this segment, we see motion-activated gestures. The user's hand movement over time is used to identify several gestures. Next, we introduce the integration of the TOF sensor with the RGB camera. Here we see detection and tracking of the region of interest based on XYZ data from the TOF component. Notice the region of interest grows and shrinks depending on the distance. We also identify several shape-based gestures from the region of interest in the RGB field of view. We show the stability of the region of interest tracking even in the presence of clutter and competing targets such as the presence of another person's hands. We show Mime's performance outdoors in bright sunlight in a typical mobile environment. Notice the region of interest identification despite several other competing targets such as people walking by. Now we present a few example interaction scenarios. We show the use of the Mime sensor to create inner drawings as illustrated by this trail. This interaction only uses the 3D TOF tracking. Mime achieves centimeter accurate hand tracking at more than 100 frames per second. We demonstrate the quick tracking response with the popular Fruit Ninja game. Again, this application only uses the 3D TOF component for tracking the user's hand. In this example, the user creates a motion-activated arc. An L-shaped gesture is detected from the RGB ROI. We also show a shortcut that selects a fixed crop region which is resized and selected. The user performs gestures to interact with the image while the photo is being taken, and the scene and desired view is fresh and alive. For details, please visit our UIST full paper.